Do you understand the formula but still get the wrong answer? In electrical calculations, the mistake is often not the maths, it's the calculator. In this lesson with Moy Academy, you'll learn how to apply Ohm's law, work with unit conversions, and enter calculations correctly. Using practical examples, we'll cover voltage, current, resistance, and scientific notation. Ohm's law uses three values: U for voltage, measured in volts, I for current, measured in amps, and R for resistance, measured in ohms. Using the triangle, you can see the three formulas. U equals I times R, voltage equals current multiplied by resistance, I equals U divided by R, current equals voltage divided by resistance, R equals U divided by I, resistance equals voltage divided by current. Check three examples of calculations using Ohm's law. Example 1. A kettle is connected to a 230 volt supply and draws a current of 9.5 amps. Find the resistance, R. Use the formula R equals U divided by I. In the calculator, enter 230 divided by 9.5, which equals 24.2 ohms. Example 2. A household heater operates on 120 volts and has a resistance of 18.5 ohms. Find the current, I. Use the formula I equals U divided by R. In the calculator, enter 120 divided by 18.5, which equals to 6.49 when we round the result to 2 decimal digits. Example 3. An electric shower has a resistance of 12 ohms and draws a current of 20 amps. Calculate the supply voltage, U. Use the formula U equals I times R. This one is simple. In the calculator, enter 20 times 12. That equals 240 volts. In this section, you'll see two examples of how to add different units. Example 4a. You have to find the total current, however, you have different units, milli and micro. A circuit has three current components: 2 amps, 150 milliamps, and 300 microamps. What is the total current, I, in amps? We are given three currents. I1 equals 2 amps. I2 equals 150 milliamps, which is 150 times 10 to the power of minus 3 amps, or 0.15 amps. I3 equals 300 microamps, which is 300 times 10 to the power of minus 6 amps, or 0.0003 amps. The formula for total current is I equals I1 plus I2 plus I3. You can check this using the first calculator method where all values are converted into amps before adding. The total current is IT equals 2 plus 0.15 plus 0.0003 equals 2.1503A. Alternatively, using a second method, we can enter the data directly in scientific notation. 2 plus 150 times 10 to the power of minus 3 plus 300 times 10 to the power of minus 6. This gives a result of 2.1503, which is the same as before. Example 4b. A circuit has three voltage sources, 500 volts, 2 kilovolts, and 2.4975 megavolts. What is the total voltage, U, in volts? We are given three voltages. U1 equals 500 volts. U2 equals 2 kilovolts, which is the same as 2 times 10 to the power of 3, or 2000 volts. U3 equals 2.4975 megavolts, which is 2.4975 times 10 to the power of 6, or 2,497,500 volts. Using the formula, total voltage equals U1 plus U2 plus U3, we can now calculate the result. Check the calculator on the right to see how to enter the data. In the first demonstration, we add 500 plus 2 times 10 to the power of 3 plus 2.4975 times 10 to the power of 6. This gives a result of 2,500,000, or 2.5 times 10 to the power of 6 volts. In the second demonstration, we add the converted values directly, 500 plus 2,000 plus 2,497,500. This also equals 2,500,000, or 2.5 times 10 to the power of 6 volts. Both methods give the same result. In the next three examples, we'll revisit Ohm's law, this time working with different units. Example 5, device with milliamps. A small electronic device operates at 230 volts and draws a current of 250 milliamperes. Find the resistance, R, in ohms. Given the voltage is 230 volts and the current is 250 milliamps, which is equal to 250 times 10 to the power of minus 3 amps, or 0.25 amps. To calculate this, we use the formula, resistance equals voltage divided by current. Check the calculator on the right to see how the calculation is entered. So, in the first method we calculate 230 divided by 250 times 10 to the power of minus 3, which equals to 920. In the second method, we do the conversion before and enter 230 divided by 0.25, which equals to 920, like the previous method. Example 6, resistance in kilo ohms. A circuit uses a resistor of 2.4 kilo ohms connected to a 120 volt supply. Find the current, I, in amperes. The total voltage is 120 volts, and the resistance is 2.4 kilo ohms. Remember that 2.4 kilo ohms equals 2.4 times 10 to the power of 3 ohms, which is 2,400 ohms. To find the current, use the formula current equals voltage divided by resistance. Check the calculation on the right. Enter 120 divided by open bracket 2.4 times 10 to the power of 3 close bracket, then press execute. The answer is 0.05 amps. In the second method, first convert 2.4 kilo ohms to 2,400 ohms. Then enter 120 divided by 2,400 in the calculator. The result is the same, 0.05 amps. Example 7, mixed units. A sensor has a resistance of 4.8 kilo ohms and draws a current of 50 milliamps. Calculate the voltage, U, in volts. The given values are, resistance, R, equals 4.8 kilo ohms, which is 4.8 times 10 to the power of 3 ohms, and current, I, equals 50 milliamps, which is 50 times 10 to the power of minus 3 amps. The formula is voltage equals current times resistance. I'm going to demonstrate this calculation in a few ways. First, enter 50 times 10 to the power of minus 3, times 4.8, times 10 to the power of 3, and press equals. The answer is 240. The brackets are optional in this calculation. Alternatively, you can convert the units before entering them into the calculator. Convert 50 milliamps to 0.05 amps, and 4.8 kilo ohms to 4,800 ohms. Then enter 0.05 times 4,800. The result is the same, 240. One more method is to simplify the calculation mathematically. We start with, U equals 50 times 10 to the power of minus 3, times 4.8, times 10 to the power of 3. Notice that 10 to the power of minus 3 times 10 to the power of 3 equals 10 to the power of 0, and 10 to the power of 0 equals 1. Because these terms cancel out, we are left with 50 times 4.8. This gives 240 volts. Well done, you have completed this lesson on Ohm's law, unit conversions, and calculator techniques. Remember, check the formula, check the units, and check your calculator entry. Thank you for learning with Moy Academy.